Wherever we go in our daily lives, we are surrounded by eye-catching signs. Company logos, designs, illustrations, symbols. They're all carefully designed to be instantly recognizable, and they tend to use the kind of colors and shapes that we respond to most readily. Graphic displays such as these are valuable information tools, which can often communicate their message much faster and more easily than words can. In these 3 videos, we hope to demonstrate the vital role that effective visual control systems can play in ensuring work operations that are smoother, faster, safer, and more productive. Let's take a look first at the basic principles of visual control systems as demonstrated in an example most people take for granted: team sports. If you think about it for a moment, visual control is a major part of most games. After all, if the players on both teams wore identical uniforms and caps and didn't have numbers, and if there were no scoreboard, it would be really difficult for the crowd to tell which player was on which team and who was doing what, and to keep track of the score and the state of the game generally. It would also make life much harder for radio and television announcers. To solve these problems, a simple visual control system was devised. Different colour uniforms and caps for each team, each player displaying his own number and name, and a scoreboard full of information to show exactly who is doing what, where and when, the present score, the number of strikes and balls, and so on. These visual controls are all very clear, easy to understand, and add to everyone's enjoyment. Let's now move inside the factory and see the same principles in operation there. Most of you are probably familiar with the PDCA control cycle. Plan, do, check, act. At the heart of all our work activities are strict standards, and whatever deviates from those standards obviously needs to be adjusted using the PDCA cycle. Visual control systems exist both to point out abnormalities, or deviations from the standard, and also to reduce the occurrence of such problems. They are a vivid demonstration of the application of the principles of the 5S system. In this overview, we'd like to look at various visual control systems in operation in actual factories to give you an idea of the huge number of possible applications. This is the operations room in an iron processing plant which controls hot melt input. Temperature control is a vital factor here. This is the recently installed FC Hot Melt Input Temperature Control Box. It is easy to see at a glance whether the temperature is just right, falling or rising. If the temperature goes beyond certain limits, then input is stopped automatically.
In the old days, we only had analog meters, but the new digital ones are much easier to read. And another good point about our new system is that it uses different colors. Previously, we used all white meters, but now you really don't have to strain to see what's happening. The colors really hit you in the eye. That helps the work of the operators a lot.
This meter used to be located much too high and was very difficult to read. Now it is conveniently positioned at eye level. An important point here. is that it is very easy for any of us to get into a condition at work where the forces of habit take over, and both our sense of problem awareness and our willingness to solve problems or consider improvements get dulled. But a well-planned visual control system serves to present problems clearly and immediately and can shake us out of our state of lethargy. Here are 4 basic visual control points. 1. What needs monitoring? Where is the critical point? And where should you look for it? 2. How are abnormalities defined and indicated? 3. How easy is checking? Can you sense anything wrong? What tool should you use for checking? 4. What action should be taken? Are emergency procedures clear? How about maintenance and improvements? Let's look next at ideas for effective use of something we're all very familiar with, files. Haven't you ever had trouble with missing files or finding just the file you want? Here we have an example of a factory which tightly controls its filing system. First, there is a clear wall chart listing all the files. But in fact, the visual control system is so good that it's possible to find files easily without consulting it. Their technique for taking out files is like this. The person leaves a magnetic name tag when they extract the file, and an identical title slip swings down to clearly mark the place of the absent file. This makes it very simple to check exactly who has which file, and also makes returning easy as well. This is a basic but highly effective visual control system. Each file also has a small coloured square on the spine, indicating the file's review period. Orange means 3 months, blue means 6 months, brown means 1 year, and green means every month. The board shows which file should be reviewed each month. This month it is April, and all colours appear. In addition, there is a check sheet inside the cover of each file, and the name of the person responsible for the contents of the file is marked at the bottom of the spine. But what about these pink spots? Well, in fact, in this factory, files are regularly transferred to different storage places, and the colour of the spots indicates where the file will be transferred to next. Pink means the central control room, silver means the record centre, and brown means due for disposal. As you can see, the secret of effective visual control is to make rules that are logical, simple, and understandable. Here's a different example, the storage of jigs. Notice how tidy these shelves are now. But in fact, the storage used to be very disorganized, and many production problems arose simply because appropriate jigs could not be found when required. The new shelves for jig storage were a great improvement. Let's take a look at the labels on the containers. They show the control number, the name of the process, and the jig's name and number. This means that the jigs are all clearly identified. Inside the container, each jig is stored ready for use. There is a clever vertical and horizontal storage policy as well. Vertically, the jigs are arranged according to type. Horizontally, they are arranged according to process. In this way, a straightforward matrix was created that has considerably facilitated the work process. As you can see, it's no problem at all to find just the jig that's required. This handmade trolley was specially designed for efficient handling of jigs. The top shelf is for jigs about to be used, and the bottom shelf is for the empty containers of jigs now in use. Previously, all the jigs had to be carried by hand, but this simple idea has made the work much easier and quicker. This is a good example of visual control speeding up the whole work process and improving efficiency. Now a different kind of shop floor situation. The pipes in this factory are painted in 8 different colours. Here are a few questions to ask yourself when you come to produce visual control devices yourself. 1. Are signs recognizable at a glance? 2. Have you marked the actual thing or place you want to monitor? 3. Can everybody spot an abnormality easily? 4. Can everybody understand the system? 5. Can everybody use the system easily? 6. Do your visual control devices make the workplace less cluttered? We hope this overview has demonstrated that visual control systems, if implemented properly, can have a terrific effect, both as a tool for bringing problems to light and organizing effectively, as well as a means of improving the general work environment. Visual control should provide genuine benefits and also be easy to use. However, care must be taken that they are really practical and used properly, not just for decoration, as sometimes happens. Let's now move on to look at 5 specific areas of application: storage, operations, equipment, quality, and safety. One of the most essential elements of the 5S system is the proper implementation and maintenance of an effective storage system for parts, tools and equipment. In part 2, we'll look at various ways of applying visual controls to storage on the shop floor.
Oh no! Bad products again! We keep using the wrong parts because the boxes look the same. It's so easy to make a mistake. I'm very, very sorry. We got the consignment all wrong. We'll store things properly in future, I promise you. Strange, I can't find it anywhere. We could be stopped all day. Hey, wait a minute. There should be 3 cases left. Somebody must have taken them without saying anything. I wish they wouldn't do that.
This kind of thing happens all the time, and the reason is really very simple. Various people use the same tools, pieces of equipment and parts, and chaos can set in when nobody knows what is stocked where and in what quantities. To avoid problems like these, strict storage control is required, so that everyone involved knows exactly what, where and how much, and also so that anything can be removed or replaced easily when needed and in the quantities required. These are the main purposes of visual control of storage. For our first example of visual control systems in practice, let's take a look at a well-controlled storage area for cutting oil and lubricating oil. This factory uses several different types of oil, so to avoid confusion, the oil tanks are clearly labelled as well as being differentiated by colour. To make sure there are no mistakes, each lubricating can is also given a label in a matching colour. And to keep the area clean, the cans all have special stands. Oil gauges are attached to the tanks to show the current oil level, and a scale at the side clearly indicates the determined limits. This is a perfect example of how to use labels and colours to avoid mistakes. Obviously, the more parts you use, the harder it can be to locate them when you need them. The second example demonstrates some clever ideas for visual control of part storage in a factory which uses many different types of parts. In this factory, the first thing they did was to make a chart showing the storage location of all the spare parts. Now let's see how their system works when you need a part. First, you look at the chart, find the code number for the item, and then dial it in. Immediately, a lamp lights up to show you where that item is stored. The parts are kept in specially designed double bins. The label on the outside indicates the part's name, number, and maker, and what the part is used for. When all the parts have been taken out, the top layer flips up to show clearly that an order should be made for more parts. The label inside states the maximum number of parts stored in the bin, in this case 4, the number remaining to necessitate ordering, 2, and the number that should be ordered, 2. The bottom layer of the double bin contains extra spare parts to avoid problems before the arrival of the ordered parts. An order request form is also attached, so that new parts can be ordered without delay. With this system, it is possible for anyone to find a spare part within 30 seconds. And it also means that action can be taken swiftly when some problem occurs on the shop floor. For our final example, let's look at a storage area for casting molds. This factory stocks dozens of different molds, and each one is used several times every day. Obviously, it is important to have some indication of which mold is being used where at all times. Each shelf therefore has a label clearly indicating the shelf number, the mold number and type, and the place of use. To give immediate information on the present location of every mold, a location chart is used. The coloured tags give information at a glance. Green means in use, red means under repair, yellow means on the shelf with location indicated, and white means being polished. The chart makes it very easy for anyone to understand the situation immediately.
この改善はですね、約100型ぐらいある型ですけども、それが以前はあちこちに置くところがですね。
Altogether, we keep about 100 different types of molds on these shelves. Before we put in a proper control system, the molds were scattered all over the place, and it could take as long as 15 minutes to find the one you wanted. It was obviously not a very efficient way to do things. We decided that the rhythm of everyone's work was being broken every time they changed molds, and there were safety risks as well. We thought it should be possible to devise a system so that anybody could find the right mold within 30 seconds, and we came up with the idea of the location chart. We decided to keep it small and simple so that you can see what's happening at a glance. As a result, our production has speeded up a lot, and there are no breaks in the work rhythm. It was a really good idea.
This is a very good example of careful storage facilitating immediate action. The storage place is fixed, and there is straightforward control of both removing and replacing molds. Let's review the 4 main points for improving visual control of storage. Point 1. Clarify the name and use of items stored. For example, by using names, numbers, and color coding. Point 2. Fix the storage place for all items and make it easy for anyone to find them. For example, by using signs on shelves, colors, and delineation marks. Point 3. Choose the best storage method for each item to facilitate removal and replacement. For example, by the use of gauges and flip-up indicators. Point 4. Decide on the stock quantity required and keep sufficient spares to avoid running out completely. For example, by using double bins. We began part 2 by looking at the kinds of problems that can occur when proper control of storage is not implemented. We hope that the actual examples of visual control systems we have just seen will give you some hints as to what might be done to improve your own storage areas. The secret is to determine the problems you have and then get everyone interested in suggesting ideas to solve them. In Volume 2, we'll look at visual control systems for shop floor operations and equipment.